Good morning and welcome to the fall workshop series offered by Pentair. This is part of the Pentair Water University. And if you have any questions during the presentation, feel free to use your chat feature to ask those questions during the presentation. If not, you can save your questions for the end. My name is Dave Emmons. I am the technical training manager for North America for everything east of the Mississippi. And on the line with us today is Mark Saunders, who's managing the chat box, who is my counterpart for everything left of the Mississippi in North America. Thank you very much for attending this morning. Now, today's a topic in the valve world or water treatment world for residential and commercial applications at point of entry solutions. We tend to think of issues as divided between city water and well water. And I think that's one of the biggest misconceptions, that one is significantly better than the other. One has a little more treatment and that's it. But we really need to understand how nations are actually managing water from what perspective. So you want to understand, how is water managed as a resource at a municipality? What's going on there? And, you know, every building has the big three coming into it, one form or another. You have electricity, you have gas, whether it's propane or natural gas, and water. The big three utilities, those monthly bills we all love to get. But they're managed very, very differently from each other. Electrical delivery, everything in the electrical world is delivered within plus or minus 10% of the voltage rating for that line. So if you've got 120 volts, we want to see plus or minus 10% before we see any issues with our electrical equipment. Why? Because if we're outside those ranges, electrical devices fail, they overheat, they can catch fire. This is critical to their performance and it's a safety issue. Digital electronics, if you're outside this plus or minus 10%, it really causes havoc with control systems. Even though we're going through a transformer and stepping it down, that variance is passed through the transformers as well. So very, very tight control of electricity. Why? Because the devices that it's servicing demand that it be in this plus or minus 10% range. Important to that utility. Now, natural gas, this is one, and this is analogous to a lot of countries around the world. Well, in North America, gas is tested every day for content BTU burn. And then the average BTU burn is averaged out for your bill. The other things about it is they limit the amount of contaminants that are allowed in it to cause corrosion and pollution. If you have too rich of a gas or too lean of a gas, it creates combustion issues. And that can lead to sooting and potentially, fire hazards with natural gases, propane or natural gas, doesn't matter which. They all have impurities of it in them. And this is really critical, that they're monitoring this every day and submitting testing and tracking this every day. Every time they get a new batch of gas in or the pipelines change supply, and they count and average this all day long. So you get a recorded monthly average of your BTU burn based on the number of therms you use, get your gas rating. We always want to see this lovely bright blue flame when we burn natural gases. Any other colors means we've got a combustion issue. So it's critical for those appliances. If this doesn't burn properly, people get hurt, whether it's from carbon monoxide or carbon dioxide being put off into a room, or sooting and potential fire hazard. So life and limb depend upon this. Now, when it comes to water, water is managed in a very, very different way. Water in the United States and for all of North America, for that matter, is managed from the perspective that water shouldn't harm you today, and it really shouldn't cause you any health concerns after 20 years of consuming that supply. That's a really, really big target to hit, very easy target to hit. So without doing a whole lot to water, we can get into that target rather easily. Water is only managed around one use, one purpose only, and that's drinking water. What's coming into the building has to be suitable to drink. And typically, this is about what goes into the pipes at the water treatment plant. So here are some of the maximum contaminants allowed, and this is for sanitizers. For chloramine, chlorine, you have up to 4 parts per million of those two sanitizers allowed in the water. And for chlorine dioxide, it's a 0.8 residual. But notice they all have potential health effects. One being consumed or overly added, which does happen in municipal treatment situations when they're shocking the system for after they do road work or whatever, if there's some sort of issue. And it's a water additive that's designed for the purpose of controlling microbes or destroying biological life. Wonderful trade-off here versus getting cholera and dysentery and waterborne diseases from an untreated water supply. But what you're trading for is a slight increase in the risks of cancers. Strong oxidizers, especially halogenated oxygenizers, tend to result in byproducts of oxidation that are potentially carcinogenic. But in reality, I would much rather take that risk long term than be exposed to waterborne diseases that could kill you today. Up until the turn of the last century, there were cholera outbreaks in Chicago, Illinois every summer because we were using Lake Michigan as a sewer as well as our source of water. And that was, something that was just a very bad thing to do, killed lots of people. So what is this standard really about? This is about health concerns only, and the primary standard here is centered around health effects. But there is a secondary standard that doesn't carry any weight of law. This is where you're going to have equipment effects and some minor health effects. Like sulfate. You have more than 250 milligrams per liter of sulfate in the water. If you're not born and raised on that water, that is essentially milk of magnesia or magnesium sulfate, and that acts as a laxative. So that's one of the reasons why you may have stomach issues traveling and drinking local water supplies, is if they have high levels of sulfate in the water. May not be anything biological. Chloride at 250 milligrams per liter, it's fine for your stomach, but really awful for stainless steel water using equipment. Very few pieces of cooking equipment that elevate temperature could survive 250 ppm of chloride. So the government is not managing your water for any other purpose than getting a drink. That's it. So here are the secondary standards, and these are all about aesthetic effects. They don't include the potential health effects of the secondary standard. Like aluminum. Aluminum has been linked indirectly to aggravating Parkinson's and Alzheimer's, but it's still used in water treatment as a coagulant. Side effect of this is colored water. Chloride, salty taste. Notice there's nothing may damage equipment. Color, 15 NTUs. That's a severely colored water. Color units above 3 are going to show up visibly, but 15 color units are acceptable. So that's where you get yellow and brown water out of the tap and they say it's safe. I still don't want to drink it. You have fluoride, and that's a ongoing debate in many circles how beneficial fluoride is. Above 2 milligrams per liter, it's a really not a good thing. And that causes tooth discoloration and accelerated osteoporosis. It's one of the reasons some people want to remove fluoride from their drinking water. Things like sulfate, salty taste, no mention that at that level it's a laxative effect. So this is taken directly from our EPA's standards. So this is what's reported. So there's more effects here than just what is published. My favorite part of this standard is things like taste, not abnormal. Odor, not abnormal. There are signs in parts of the southern United States and around the country where you may find placards at hotels that say the yellow color of this water is normal and it is safe to drink. That doesn't really give us a whole lot of warm, fuzzy feelings about the safety of that water when it comes out of the tap colored. So very, very relative standard here about to what is normal. But you notice the vast majority of these things are bacterial, heavy metals. This is really a health-centered standard, not necessarily on appearance or aesthetics either, mainly focused on health. So there are presently 90 contaminants on this, the Safe Drinking Water Act in North America, and these are analogous around the world. So if you're going to want to web search the standards for your communities, your cities, and your countries to make sure your water is in compliance, you'll find a lot of similar legislation throughout the world. In North America, we have a waiting list of 2,600 substances to be included on this list. It's decided by a panel, and then to determine whether or not it's cost effective to regulate that contaminant. We're seeing that with things like PFAS, PFOAs now in North America, where we develop the ability to test it, but there's no standards now around it. So it's going to go into that standard development phase, which takes years to get through, and then takes an act of Congress to enact it in the law. So there's going to be a myriad of substances that are never going to be tested for. That's the outtake of this, is there's possibly things in your treated city water supply that you aren't going to want to consume. From the sanitizer down to any number of a myriad of other substances that are never going to be regulated because it's not deemed to have a large enough health effect. So it's just one of those things that this also doesn't take into account impacts on your equipment, on your ovens, your washing machines, your dishwashers, your water heaters. I've got 5 kids. I can't afford to be replacing all my water using equipment sooner than the lifespan of that equipment. I need to get that lifespan out of that equipment. That's why I manage my water at home. Makes economic sense for me where I live. The other thing is the analysis of these samples typically takes place at the treatment plant. And it's only when you get into population centers of 100,000 or more that it's required that they actually go out and test samples being delivered at the tap. So what that means is we're not typically testing for what is coming out of the pipe. We're testing what goes into the pipe. And that pipe in the ground is, in some parts of North America, is over 100 years old. We still have wooden water mains in use in some of our largest cities that have been collecting dirt and debris since the colonial era of the US. That's amazing that we still have infrastructure that old. We have lots of lead infrastructure, lead service plumbing in the ground out there that's causing us issues now. Another big issue in North America is removing that lead service plumbing. So the focus of this act is on aesthetic effects, undesirable tastes and odors, get it down to an acceptable level in air quotes, cosmetic effects that don't damage the body but are still undesirable. And the technical effects that this takes into account is about the water treatment plant and the plumbing in the ground, not about the equipment that's using water. Once a contaminant is below that maximum contaminant level, it's considered safe. So if we've got some arsenic in our water, but it's below the standard, it's considered safe. Well, I don't want to consume any arsenic, even if my government says it's safe. I want that out of my water supply. So that's what we're talking about here is with this, is these are about getting stuff low enough that it's not going to harm you today and shouldn't harm you within 20 years. It's that shouldn't harm you in 20 years aspect of this that we need to manage for ourselves. Oh, what happened? Sorry about that. That just took a nosedive out of nowhere. I apologize for that. Here we go. Let's get us to where we need to be. So this is some recent tap waters in North America. This is what the Flint, you've heard about the Flint River, Flint water crisis. This is what happens when you put too corrosive water into the plumbing that's not ready for it. We need to manage water better. And this is what was stripped off of the pipes and then dissolved lead. This is what was coming out of the ground. This was a water sample or someone's tap in Pennsylvania. The community well had tapped into a natural gas main. Nobody could smell it, and it was coming out of the well water pipe through the pipes. So we want to understand we need to manage these waters. And this, you're seeing pictures here of source waters. This is the Cuyahoga River in Ohio. And this is 1976 through 80. There was so much chemical dumping into this river in North America. And this river is the source water for several large cities in Ohio that it would spontaneously catch fire. So this was your source water and your sewer pipe all in one. And that's really what the Safe Drinking Water Act was about managing, is that we're going to get rid of all of this. And then the Clean Water Act was on the backside, preventing it from being dumped in. So we've come an amazingly far way since the 1970s on water quality. And this was the driving factor. This is, some of the events that drove us to create legislation. Water, rivers catching fire on their own and burning for days. And this is all chemical fire. So the fumes coming off this were rather toxic to begin with as well. So this was not a fun time to live through if you were in Ohio with this river catching fire. So sources of contamination that we don't often think about is farm runoff. In North America, if you look at this, wrong slider. If you look at this, essentially you're seeing the colors in yellow, orange, and red are increasing contamination. This is farmland that's producing runoff of fertilizers. And if you notice, the Mississippi River runs right through here. That drains from this mountain range to this mountain range. So that's all building up in this water supply that serves many metropolitan areas in North America. So agricultural runoff, nitrates, this exists in our water supply. This is food for organic things. This is where you get algae outbreaks and biological outbreaks because we're fertilizing the water in our fields. Toxic discharge in the United States. I love the overlay of the rivers because it shows the drainage. This corresponds to large-scale chemical and agricultural impacts. And you can see these systems are all linked, and they're all ending up, we're all downstream of somebody else. So this is understanding your toxic discharge. Understand you need to have treatment to manage the trace amounts that you're going to see in your water supply. Because remember, all these municipalities are concerned with is getting things below that maximum contaminant level. So where does sources of groundwater contamination come from for wells, if you're dealing with wells? The vast majority of it is sewage and septic tanks. Then it's runoff. And if we want to look down this list, industry really doesn't show up until you get to oil and gas brine pits, saltwater intrusion, other landfills, road salting, land applied sludge from wastewater treatment, waste sites, mining, construction, and injection wells. So all the industry we point the finger at the most is at the lowest end of our contamination in our culture. Most of our contamination comes from sewage and septic tanks. And then the rest of it is nitrates, which is fertilizers, and synthetic chemicals. It's all of human life, from pharmaceuticals, petrochemicals, all that stuff are on the higher chains of all of these things than industry. It's surprising, but sewage is the biggest contaminant. So we have two utilities that are managed very, very consistently, day in and day out, that have to hit that target all day long, or you have potentially dangerous situations. Water is supplied in a very, very broad range that it will not quickly harm people, or plumbing infrastructure, municipal infrastructure. But water is not delivered with any consideration of your water using equipment or your very long-term health. It's get it below a certain level and we should be good. It's mainly pathogenic and extreme toxin protection. So that leaves us managing that difference between acceptable for you to drink and acceptable for your equipment to use. And do I have any health concerns that I want to manage as well? So if you have any training requests that you'd like to set up specified training for your organization or yourself, feel free to drop us a line at training.request@pentair.com. If you just want to talk shop or talk applications, we'll do that well. If you have any issues with product, pro or con, we'd love to hear that as well. I'm going to go ahead and open the lines to questions now. But the interesting thing about water is, having seen all the water reports that I get, municipal water reports that I get to see in a day.
Hello. Hi, David.
Hey, good afternoon or good morning. I'm ahead of myself.
Yeah, good afternoon. It is in our time.
Yes. You know, I actually give away drinking water ROs for holidays, just because I know, after seeing so many water reports from around North America, Europe, and I was involved with some international projects, that they make wonderful gifts simply because there's a lot of stuff in water out there that just isn't treated for by our municipalities, and that we need to take ownership of on an individual level to ensure, well, health and safety in our own homes. So are there any questions?
Hi, David.
Yes.
David, I have one question. My name is Kamal. I'm calling from India. Are we doing any training for our tanks, like our polyglass and our composite tanks?
We're doing any cleaning for them?
No. For their basic technical specifications like distribution kit, how to fix up the distribution kit, or overall their quality and experience, like whatever we as a salesperson can give the major technical aspects to our customers, so that we can have more sales of those tanks.
We're putting together a tank presentation for later in the year. If you need some more hardcore data,
Okay.
I would suggest reaching out to Joel Wojtek at Chardon, who manages that group, for lack of a better phrase for what he does. But we can get you some training materials or materials that will outline their specifications for those tanks and their chemical compatibilities and things like that. We do have that data. I just don't have it at my fingertips right now.
Okay.
It's for tanks. They're kind of a commodity item, and sometimes that's just based on dollars. So we need to develop some differentiation points, things like dome hole tanks where you're able to inspect, and the low profile tanks for softening that allow you to remove the flange at the top of the tank, for bolt-on designs that would allow you to get a commercial tank into a space where you couldn't by saving a few inches. There's those sorts of things that differentiate us, and the fact that we are the only company that has ASME certified fiberglass tanks that are available on the market. So if they need ASME certified tanks, we can get those for them. But those are essentially built to order, and for every one that we sell, we destroy one in testing. So those are very, very highly certified tanks.
Okay. NSF approved also.
For what products? The tanks?
Yeah, tanks. Yes.
I would have to.
Actually, I'm handling my distributor network in India, and I'm having 4 or 5 distributors. They are having sales people who are handling overall regions for final sale of tanks. So we just want to increase our number of customers, to increase our polyglass and composite and FRP tank sales in India.
Okay. So they're looking for some sort of certification on the tank it's suitable for water contact, correct?
Certification I already have. I think NSF approved is we have, and we give 5-year warranty of our tank body, I think. So overall, yes. Overall I have, but some of the distributor sales people don't know much about technical about those tanks. If they sell it to the customer who want to have a system, like they want to make softener system, or they want to make a WTP system with the dual media filter or something. So some people do not have much idea on that.
Okay. No, we can definitely. We're actually building out a tank training deck as we speak.
Okay.
We have some legacy stuff, but we're building it out with a perspective at end use. But that'll be coming up a little later in this series. But once
yes, I have that.
We can.
Yes, I have that PDF file. Yes, of trainings till December. Yeah, I have that.
And we can get that over to you once we've got that finished up.
So can I register my distributor people for that trainings? Whatever is given in that.
Absolutely, okay. more than merrier.
Okay, I'll do that.
That's exactly what this is all about. Is spending a little bit of time with people.
Yes.
To touch base and reinforce little things, because we all miss those little details from time to time. We can all go deeper into these subjects, but I found 15 minutes to a half an hour fits into people's lives. So
Yeah, that is fine. That is fine. 45, 50 minutes are fine for that.
yeah.
Only the thing is in India right now, time is around 8 p.m. So everybody is not having that favorable timing. Generally, people look for afternoon timing, 3, 4 p.m. something. So
Yeah.
timing is not much suitable, but we will handle that. I have already discussed with my distributors.
Well, we are
People are interested.
we are recording these as well, and I should probably stop this conversation. And they will be located